What's up?
I got the majority of it.
All right, guys, let's take a look. So if you want to do it in the calculator, remember if you, let's do this. See how my L3 is gone now? Just to remind you guys, see how my L3 is gone? Put a little L3. I'll hit Stat, Setup Editor. Then I'll go back to Edit, and now L3's back. Oh, okay, so don't forget that, because that'll throw off things. Try and use a list and one of them's gone. That will definitely freak it out. So L3, I'm going to go up to L3 if I want to use the tables. And I'm going to do X, which is L1, times P of X, which is L2. Kabam. So those should all look familiar. And if I go to L4, I want that. I could either do L1 squared times L2, but I always just do L1 times L3. It doesn't really matter. There's less tightening there. One less button I have to push. So hopefully those look familiar. Now, you can do list, math, sum. Now watch this. If I do this, I can even just hit 5. I can sum. I want sum of L3. Now watch. One of the coolest buttons on here is second enter. Brings up the last shit you did. And then I can just go back and replace that with L4. So I don't have to go hunting for sum again. You guys with me? What's up, guys? Everybody all right? What's going on? You all right? What's up? Okay. All right. Speak now or hold your peace for a little bit. Okay. So that's going to be, so this is 45.89. And that kicks ass because that's the mean. And then this is 2410.89. Now notice I asked you these questions before you even do anything with this table, right? Before I tell you to do anything, I say, verify it's valid. Okay, so you don't have to know any of this shit to do that. All the probabilities between 0 and 1, they all add to 1 or close to 1. And here, we've got to get over, at least, we've got to understand what that means. Right? You have to be at least this tall to ride the ride. It's that tall or more, not that tall or less. That would be at most. That's like you could be at most 12 to eat off the kids' menu at Denny's, right? Then, okay. So now watch. What's at least 25? Which ages are at least 25?
All of them but 21.
Yeah, so you can either add all these probabilities up to see, or since all of these add to 1, you can just do 1 minus 0.04. That's the idea of the at least one thing more generally. The opposite probability's got one thing, so let me just do 1 minus that. That's quicker. Or add these up, I don't give a shit. Right? You're going to get the same thing, you should get 0.96, right? So 96% chance they'll think there'll be at least 25. Of course, what do these think? These people are thinking, oh, I'm going to make something like the next Facebook, or I'm going to be a YouTube star. Yeah, whatever. No. Don't have a backup plan. Oh, is it? All right, what about, so now you just got to, this one I know. What's this? What's the mean? Yeah, 45.89. I got some work to do for the variance, right? What's this? Yeah, 2410.89 minus the mean squared. 2410 minus 45.89 squared. You get 304.9979 for the variance. And then I can just do square root of answer because that's the last number on the screen, 17.464 is what I get for the standard dividendation. Now, don't worry, I'm okay. I want to show you the quick way to make the calculator do all that for you, which is a way to check your work again. You guys should all be familiar with my mantra, don't tell me the buttons you pushed do the frickin' work, but check it all day long. How many variables are there in this problem? And I love this question because you always forget how to answer. How many variables are there?
1.
Beautiful! 1. Not 6. There's 6 values for the one variable. So I can do one variable statistics on this problem. But what column has my data in it? This is a trick question, I'm telling you right now. What column has my data in it?
The P of X.
Well, no, because that's just the probabilities. L1 and L2. And why does that make sense? Because that's what I had to give you for you to do this problem. That's, to give you the data for this kind of problem, I have to give you the x's and the p of x's. So now you don't have to do what I'm about to do. But it's a way to check your work, right? So watch this. So go to stats, calc, Jeff, calc, 1 var stats. But where did we just say, now look, freaky list. Relative frequency is also known as percentage, which is also related to probability. So let's just put the list where your probabilities are. So it's going to do xp of x for us. Anything familiar? Everything looks familiar. Yay. All right, there's my mean, there's my standard deviation, right? By the way, I didn't say this. Do you see how S doesn't even show up? What's supposed to be on the bottom of S? The formula for S. N minus 1. But what's on the bottom of probabilities? Ah, shit. So, since I'm multiplied by P of X and it has an N on the bottom, these are understood to be mu and sigma. Maybe. So that's a way to check your work. Why does it say N equals 1? That's really weird. That's the same thing as saying the sum of the probabilities is 1. So that's another way to check things. Yes? Yeah, you just have to, the same way we go to stat, calc, one variable statistics. Remember that's how you can see the 5-number summary at the bottom? But now don't just say L1, say L1 and L2 together. And then you calculate. Ah, shit, I lost L1. Then you get all this. If you have the older calculator that just says 1 var stats and a little blinking cursor, say L1 comma L2. Watch, this is actually, if you do this, I'll show you. See, that's how it would look like on the older calculator. For the old calculator. Okay, how are we feeling? You don't have to know how to do that at all. I don't care. I'm more curious if you know how to do it by hand. In the real world, you're probably not going to use the TI. You use some program on the computer. So let's see. Go ahead. Finish this up. All right. This should sound very familiar. Right? I keep doing this to you because we have so many theorems and all this stuff about the percentage that's within 1 or 2. So I like to do this to you. What goes in the middle?
Me.
Yeah, 45.89. If I add one step, where do I end up? 63, blah, blah, blah. And then if I subtract 1, I end up at 28 point, blah, blah, blah. Whatever it is. I like it. Yes?
How many actual decimal places do you want us to go out?
For this?
Yeah.
1, because all the data points are whole numbers. All I need is enough information to know what data points I caught.
You put more, you won't take out?
Yeah, no. So what data points did I catch? I caught all the 40s, right? Did I catch the 25s? Did I catch the 25s?
No.
No, because they're down here. Did I catch the 50s? Yes. Did I catch the 65s? No. So it's not 2 out of 6. No. I caught all the 40s and all the 50s. So what percentage of the data did I catch? 41%. Yeah. So it's probability of 40 plus probability of 50. It's 0.41, 41%. So this is different than if I just give you a list of data, then you do so many out of how many total data points. I've got the percentages. I just add the percentages up. I'm done. I don't have to divide anything. They've already done the percentage work. But it's basically the same problem. Okay. Maybe. And then finally, how many total kids did we talk to? So 100. So how many kids believe they will retire before age 65? Well, what percentage believe that? Before 65? Who? What percentage think they'll retire before 65?
69.
69%. So I'm going to take 69% of 1,200 kids, right? What does this mean? What does 4% mean? What does that right there mean?
21 kids is 4% of.
What? 4% of the kids think they're going to retire by age 21. That sounds realistic. So 69% of the kids think they'll retire before 65, so 69% of 1,200. And what is that? Whoops. That's times. Get out of there. Who is it?
820.
828? So 828 kids. Before age 65, that's doable, but before age 21, it's not going to happen for most of us. Obviously, I've kind of lost my shot at that. Okay, how do we feel about that? That's exactly the kind of questions I would ask you about those. When do I use those formulas with x and p of x in them? Probably when I give you a table that's got x and p of x in it. Okay, cool. All right. Moving on. If there's no questions on that, we're done with 4.1 and 4.2. We're going to get into 4.3. Oh, yeah.
Equation list for tomorrow, or we can do that ourselves?
Oh, yeah. Shoot, I forgot all about that. Let's do that real quick. Thank you for reminding me. Let's make our formula sheet. Can somebody bring the lights back up? Thank you. I should have done this earlier, but let's do the formula sheet for tomorrow's quiz, and then we'll get into 4.3.
Hey, Professor.
Yo.
We're having the mini test that day. Are we leaving after the mini test, or are we going?
Double quiz, so we're not leaving after that. It's about twice as long, counts twice as much, but it's just a quiz. I'm not going to give you the whole time to do it. So we really don't have that many formulas. That's it. So you put these on a piece of paper that only has these things on it. No other markings, no anything scratched out, no torn off bits. Any of that happens, I assume the worst.
We're writing a formula sheet on the top.
Yeah, you could have the words formula sheet. I always love it. I love people do something in a different language, or that's so awesome. Don't do that. I take off a lot of points because then I don't even know what the note is.
And This has to be turned in with the.
Yes, you'll turn this in with the quiz. And then I'll give it back to you so you can use it for later. So every test, you can just keep bringing back all your formula sheets, as long as you didn't lose points for them, because you'll lose it again. That would be really stupid. Okay. Anybody, any other formulas you think you should have from chapter 3?
Can we put like actually never mind, because it's the same thing, just does not equal 0.
Oh no, yeah, you can't have notes.
Well, it's the same formula you put, does not equal 0.
No, it's not the same formula, it's an idea.
Yeah. Well, technically, it is, but it does not equal 0.
That's an idea. It's not a formula. What doesn't equal 0? What would you put that next to?
The probability of A and B.
Ah! But that would be a note to know if they're mutually exclusive or not. No, notes are not allowed. By the way, huh? Evil? You like it. It's evil and you like it. Okay. I'm okay with it because I'm not trying to be evil, but just to show you an example of how a formula can be a note. Does anybody remember? It's not going to be on this next quiz. It will be on the next 2 tests in the final. There's a question I told you that will be on every test in the final. Anybody remember what that question is?
What is the z-score?
What does the z-score tell you?
How many standard deviations were
To the data point. I like it. And there's a formula we created. Remember this formula? Look what it says. A data point is this many standard deviations from the mean. So what's the z-score tell you? The number of these from the mean to the data point. Math is a different language. You can translate it into English. So some of these formulas, I will point out, they are notes. And some of you will understand that. And that's awesome. Then you'll have a quick way to remember the definition that you've already gotten, which kicks ass. All right, enough of that. Is there anything else you want to have on the formula sheet? Okay.
What about the mutual exclusive?
Which one?
The mutual exclusive.
No, again, that's an idea. What's it take for 2 things to be mutually exclusive? The probability of, for the 2 things to be mutually exclusive, what's got to be true? Probability of A and B is 0. That's an idea. You see how I'm not writing it down on the formula sheet? So neither should you, or else you
Say one
lose
more
points.
time. So I can get it.
Mutually exclusive means A and B can't happen at the same time. Therefore, the probability of A and B would equal 0. So if the probability of A and B is not 0, that means those 2 things are not mutually exclusive. Bless you. You guys, the look on your faces, I love it. First time I've ever heard of that, John. Oh, shit. Yes. Which one? Oh, okay. I won't put cards on there, like I said, because I know there are people that haven't spoken up when I asked, and they're not really comfortable with cards. So I'm going to make like the problem with the candy bars, or the various political groups that I put into a haunted house. Right? Something like that. I'm not going to put cards down there, because then if you know real cards really well, you have an advantage over somebody that has only ever played Uno or something. You're like, what the hell's a king? What do you mean one-eyed jack? What the shit? Okay. Is there anything else about that before we get into 4-3? So this is for the quiz tomorrow. All right. I know I keep saying this, but I love 4-3. We're going to create the formula. It's just going to naturally come out. It's crazy if you let it. So I'm going to set up a situation that sounds like we've done it before, but not quite. It's a little more complicated than anything we've done before. I'm tired of talking about freaking left-handed. Let's do, let's say the probability that, what do I want to talk about?
Help me out. I'm at a low creative ebb at the moment.
Someone has 4 toes instead of 5.
So, wow. No, let's do, huh? Who?
She said eye color.
Eye color. Okay, I like it. So probably somebody has brown eyes. Let's see, how many of you guys have brown eyes like me? Meaning we're full of good ideas. How many of you guys don't have brown eyes? Oh, yeah. All right, let me see. So let's say, all right, let's make it easier on ourselves. Yeah. So let's say probably somebody has brown eyes is 78%. Based on my empirical observations of this class. A lot of us have brown eyes in this class. And it is, I think, is the most likely eye color. I think it's a dominant gene or something. Okay, if you're blue-eyed, nice for you. So what's probably that somebody does not have brown eyes? Who? 22. So let's write this as we should. This is not a number. This is a number. This is a number. Percentages, always change them to decimals. Because the percentage is something we made up completely as a human. Let's make it into what number it is. All right. So let's say I pick 5 people at random. Let me see. Doesn't this sound like a question I've asked before? What's the probability that exactly one of them has brown eyes? Doesn't that sound like something I've asked before? I have never asked this kind of question before. And the reason I haven't, I have asked this question. What's probably the first one has brown eyes while the last 4 don't? I've asked that question. But why is it not the same as this? Why is this more complicated?
Because it's exactly what
Okay. So it's less specific. The way I've asked it before is the first one has brown eyes, but the last 4 don't.
It can be any one.
Yes, there are several ways for this to happen. In fact, let's do 2 things. Okay. So, I mean, if exactly one has brown eyes, which one could it be? How do I get a probability? I add up everything that matches what I'm looking for, right? You with me? That's why when I was doing the at least 25, I added up all the probabilities that were at least 25. I add up what I'm looking for. So let me do 2 things. See how I'm looking for people with brown eyes? So that would be a success, right? And a failure would be not brown eyes. So success doesn't have to be nice. I could be looking for dead bodies or rabbit squirrels, right? Success doesn't mean yay. It just means I found what I'm looking for, right? So let's call the success probability, let's call it P. And the failure probability, we'll call it Q. Not like we have a choice. This is what's been determined already. We're going to do this because it's the way it is. So mind your P's and Q's doesn't come from this, by the way. And I don't think it's pites and quarts. I don't know what it is. Okay, I'll stop. So let me represent. Here's the way related to the question I asked about the first one has brown eyes and the last 4 don't. Do you see how that's that situation? First one has brown eyes. That's a success. So I'm going to denote that by P. And the other 4 are failures in this case, so I'm going to call them Q. You guys with me? Why am I multiplying each time? Because this is the first one has brown eyes, and the second one it doesn't, and the third one doesn't, and or means add. Or what's another way to have one person with brown eyes? Does it have to be the first person? No. It could be this way. Bear with me. This is why I just made it 5. Just let that P, oh, that's going to sound great, Jeff. I'm going to say it anyway. Just let that P float through there, right? I don't think I've ever said it like that, but oh well. You guys, does everybody understand what that physically represents? That's 5 different situations of 5 people where exactly one has brown eyes. It could be the first dude I picked, or the second, or the third, or the... So thank God it didn't say 80, right? What we're about to do gets remarkably harder. What we just did, we made a little list, right? But if I did have 80 people, and I wanted to know that probably exactly 3 of them had brown eyes, It could be the first 3, or the last 3, or the middle 3, or the first one, and the 7th one, and the 80th one, or they could, holy, do you know how long that list would be? That list would be stupid long. Have you guys ever heard, if you have like 11 options for the toppings on a pizza, how many pizzas you can make? It's like 7 million something. The human mind can't quite grasp that. Same thing with the pairs of people in the room related to the birthdays thing. Our brain doesn't go there automatically. You guys have heard that, right? The pizza topping thing? No? Google it. Now look, mathematically, what does math say each of these looks like? What is P times Q times Q times Q times Q? What's a better way to write that? Yeah. All of these look like that, right? So they're all like terms. So how many of them do I have? 5. Where'd that number 5 come from? It's how long the list is. That is the one piece of this that I'm going to make the calculator do for me. Because like I said, if you got 80 people and you want to pick 3 of them, that's going to be a long freaking list. I don't want to make that list. I'm going to have the calculator count it for me because that's what they're good at. So we'll get there, don't worry. So I can calculate this probability now because I know what the value of P is. What's the value of P? What's the value of P? 0.7. So the value of Q, bless you.
0.22.
So do that in the calculator real quick. Good. Crowdsourcing this.
0, 0, 9.
So what do you guys get? 0, 0.
9, 1, 3.
Anybody else playing along?
Yeah. Yes.
Okay. Not that I don't trust you. It's always nice to get verification, right? Okay, okay. So again, the hardest part of this is that number 5. It wasn't hard here at all, right? But let me show you how that quickly becomes an issue. So same problem, let's say, right? This is part 1. So part 2, let's say that I picked, like I said, 80 people. What's the probability of that exactly? Let's say 66 have brown eyes. I don't know if you can really wrap your head around. First off, you'd have to write 80 letters for a single row. But then what are you doing? You're picking 66 to make P. And how many to make Q? 14. Right? So they could either be the first 66 and the last 14, or they could be the first 33 and the last 33 and the middle 14, or it could be the first 2 and then you have it and then you skip. And then do you understand how that would be a long, tedious list? But I know already, so I don't know the number to put here, where the 5 is. But what's the power on the P going to be? Why was the power on the P here 1? Because I wanted 1 success. And why was the power here 4? Because I have 5 freaking total. So of course I want the rest to be failures. So what's going to be the power on the P? Yeah. And what's going to be the power on the Q? Yeah. See? So that part I can set up easy. And then I'm going to put what P is and what Q is. But this is the part we're going to have the calculator help us out with. Anybody still not have a calculator? I think a few of you guys borrowed one. Anybody want to borrow one? Okay. Since we have this already here, can somebody? Thank you. Oh, you just went for it. Okay. That's all right. All right, guys. So here we go. Let me first verify this is 5, and then we'll figure out what that's supposed to be. So now watch this. How many people did I pick total? 5. And how many did I want to choose to have brown eyes each time? 1. Bless you. So there's an idea in probability, really, that's counting how many ways there is to choose 1 out of 5. And the beautiful thing about that is, first off, let's everybody put a 5 in here. I got 5 people. I want to choose 1 from that list, from those people, right? So look here, go to math. There's a math button. That should intrigue you, right? One thing is look how it can make things into fractions, but too bad. Go to probability. Which one looks like it's related to choose? No. Choose. Probably the one that's got a C in it. What does N mean? Total number. So isn't that like 5? Choose. Now they use an R, we're going to use an X, but that means the number of successes. So that's my choose button. 5, choose 1. Now if you have an older calculator, it's not going to look like that. It's just going to 5 NCR 1. So this represents the number of ways you can pick 1 person out of 5 people. So of course it should be 5, right? So if you hit enter, you get 5. Now, what do I want up here now? How do I set up what I want up here? Shoot. Everybody at home just missed what I did. That's too bad for you guys. What do I put here? What choose what? Don't turn the lights on, don't worry about it. Yeah, 80, choose 66. That's what I need there, right? That's how long that list is going to be. I don't even know if the calculator can handle that, to be honest. Let's see. 80, choose 66. Ooh, dude. What does that mean? You still missed out. Poor people. Anyway, come to class. That's going to be a neat part of that. What does this mean? 1.5? This means move that decimal 15 times over. Holy shit. Do you want to write that list? Considering one line would take 80 letters to write, and I've got this many lines, I don't want to do that. Alright, so normally we're not going to just put that in by itself. I just wanted to show you how long that list would be. Okay? Let's put the whole formula in. Can you bring the lights back up? Yeah, thank you. So let's first write the formula. Let's fill in what we got here. So I got 80, choose 66. What's P? And I want 66 of those. So 80 people, choose 66 of them to be brown-eyed. So I want 66 successes. And how many failures? Yeah, the rest, 14. And now let's try to plug that in the calculator. So let's just start. I'm just going to start fresh. 80 math probability, choose 66. Now here's what sucks. You have to hit the over arrow to get up out of the bottom. Unless you have the older calculator, you just keep going. Times, is everybody with me right now? Make sure you're not still in the subscript because it's going to freak it out. You're going to get all kinds of error messages. So 80 choose 66 times 0.78 to the, what was it? 66. Hit the over arrow, it'll come back down. Times 0.22 to the 14. Let's all make sure we get this. Okay, how are we all doing? Are we okay? So there's like a 7% chance, roughly, that for any group of 80 people, there will be exactly 66 people with brown eyes. You guys all right? Oh my God. I can't imagine playing poker with you guys. I'm losing money left and right. What do you got? Because me, I'd be like, I can't hide. Like, I can't. Okay.
So she wants to write like 07 or 07.
What do you think? What do you think you're going to write as the answer? What's the answer going to be?
0.07.
Nope. We know better.
07.
0709. 4 places. We know this. Very soon you'll see why I'm making it 4 places. Something we're going to use a little chart. It's going to have decimal up to 4 places. I want you to get used to it now. All right, let's do another one together, and then I've got, amazingly enough, I've got a handout to work on this. Let's do a different situation. Let's say I could look it up, but I'm not going to. Let's say 17% approve of the job Congress has done over the last couple of years. I might be being generous, but we'll see. You guys with me? And we pick, what you got, Jeff? 38 people randomly. What's the probability that at least, no, let's not go there yet. Exactly, what is it, Jeff? Let's say exactly 8 approve. Can you guys see how you can tell the type of problem this is? I know we just got into this, but they approve, so there must be some that don't approve. There's 2 things. This is called, by the way, I haven't said this yet, this is called a binomial probability. Why is it called binomial? 2 things, right? 2 possibilities. Everything can be broken down into 2 possibilities. Even if you roll a die. How can I break that down? 5 or not 5? There you go. Right? You pretty much always summarize these things for yourself. What's n in this problem? 38. What's p? 0.17, yeah. So what's q? 8.3. Because what's p plus q got to be? 1. Because that's everything. Right? And what's x? Anybody remember what I said x was? No, that's n. X is what can vary in a given situation, and what can vary is how many successes I want. 8. So let's set up the equation. Oh man, part of my brain just went, do I have money for the ice cream? Because it did sound a little bit like that. No? Alright. I didn't mean any bad, whoever did it. How do I set this equation up? What's the first piece going to be? How many people I got? 38. How many do I want to choose? 8. So how many successes do I want? 8. And how many failures do I want? 30. Because what do these 2 powers have to always be? The total. Because if you ate a success, then you a failure. Right? There's no shades of gray here. And now I just throw that in the calculator to see what you can get the right answer. I'm going to write up here the formula. This part always freaks people out, but how did we get 30? We did total number minus successes. We did n minus x. Okay, that's the rest then.
How'd you get 0.83 again?
Well, if 17% approve, how many don't? The rest. Yeah. Those 2 always have to add to be 1. So what do you guys get?
0.1%.
All right, let's see if I get the same thing. You never know. No, not doing that, you won't. Choose what? 8? Yeah. What did I say? 17 to the 8th 0.83 to the 30th. Yeah, 1274. Yes? Okay, let me give you this. Here we go. So I want you guys to work on this. Oh, there's one more thing I gotta say. Let me just give this out to you. What's up?
I got 0.
You got 0 for what? Here, hold on.
Grab a calculator.
Oh yeah, good. Shit. Sorry. Well, I have no stock in them, right? Let's give that as an option. Sorry. Yeah, this is weird. It's coming. No, forget it. All right. So let's see. Where'd you go? Figure it out. Jude, yeah. Yes. Yeah. Good. Keep going. Yeah, so the older calculator doesn't put it in that special format. Just keep going. Yes. Yeah, so you get the same issue, just keep going. I gotta ask you a question. All right. The last thing I need to tell you, guys, what would you expect from a group of 38 people? What would you expect? How many would you expect to approve of Congress? 17% of them, right? And the expected value is another name for average. So the average is n times p. Oh, that's the best frickin' mean formula yet. Why does that make sense? Well, if I make 60% of my free throws and I take 20 of them, I expect to make 12. I expect to make 12. Well, I always make 12. No, that's an average that I should expect to make, right? Now here's the freaky part. I know this is on the paper. I can't really show you all the math behind why this is, but there's what the standard deviation is for an NPQ problem. No charts to make. Oh, that's the easiest mean and standard deviation yet. So go ahead and try this sheet out. Again, it's not a quiz or anything, so